All right, we live, y'all. Let's get it. You already know what it is, man. Here, another video to learn how to code going to CS50. As you heard, all right. Um, let's get into it. Make sure my sound is good over here. Let's get into it. Make sure my sound is good over here. Let's get into it. Make sure my sound is good over here. Let's get into it. It's looking good, y'all. It's looking good. Let me put this on the charger. Put on D&D. We're gonna get a couple, maybe an hour or two on this coding before I hit the bed, man. Appreciate y'all for tapping in, man. Last week or last video was pretty cool. I had a lot of people tapping in talking about crypto. I had a guy trying to make me a meme coin, and I was like, I'm good, bro. I ain't trying to pull no rug on nobody. So that was interesting to see how this is coming together. But I'm just really trying to learn the code, and I know there's no code tools out there, y'all. But whenever I'm using Cursor or Bolt.new or any of these tools, I don't even know what I'm doing. You know what I'm saying? I guess that's the point in a way, but I want to know what I'm doing. I want to be able to really build out, and I'm not even talking into the mic all up. I want to know how to build out everything I want, and yeah, just really dial it in. So, with that being said, let's get into this, man. Let's get into this entire screen. Screen one, share, and yeah, let me get this. Let's do this like.
Let's talk about operators in C. So we've already seen one, in fact, equals, the assignment operator. It allows us to put a value into a variable. That's the assignment operator, single equal sign. In order to manipulate and work with values and variables in C, we have a number of operators at our disposal that we can use. Let's take a look at some of the common ones, starting with arithmetic operators. As you might expect, we can do pretty basic math operations in C. We can add, subtract, multiply, and divide numbers using plus, minus, star, and slash, respectively. Here's a couple of lines of code in which we do that. So we have int x equals y plus 1. So let's assume that somewhere up above this line of code, we had said int y equals 10. What's the value of x after I execute this first line of code?
What that boy say? I'm running it back.
Let's assume that somewhere up above this line of code, we had said int y equals 10.
Okay.
What's the value of x after I execute this first line of code?
11.
Did you say 11? You'd be right. Why is that? Well, y was 10. So I'm saying int x equals 10.
He asked that kind of weird.
10 plus 1 is 11. So the value 11 gets stored in the variable x. Not too bad, right? How about this next line of code? X equals x times 5.
So 11, 55.
Well, before we executed this line of code, x was 11. So what is the value of x after this line of code? Take a second. So x equals x times 5. X was 11. So x equals 11 times 5, or 55. So if you said 55, you'd be right. Now, it's maybe a little confusing, but with the way that assignment works in C is the value on the right gets assigned to the value on the left. So first we evaluate x times 5. So 11 times 5 is 55. And then we
What up, people in the chat or in the room? I see two people in here. What up, y'all?
store that value in x. The 11 that was there before is now overwritten, and so x's value is now 55. Hopefully that's fairly straightforward. There's another operator that you've probably not necessarily heard called this, but you've certainly worked with in the past if you remember your days of long division way back in grade school.
Nope.
It's called the modulus operator. What modulus does is it gives you the remainder when you divide two numbers together. So if I divide 13, if I say 13 divided by 4, what's the remainder? And that value would be calculated by the modulus operator. So I have a line of code here, int m equals 13 mod 4. And I say here in a comment that m's value is now 1. Why do I say that? Well, do the long division out in your head if you bear with me for a second. So I have 4, 9 divided by 13.
4, 8, 12.
4 goes into 13
1.
3 times.
Okay.
with a remainder of 1.
Yeah.
So that's basically all the modulus operator does, is it tells you when you divide, you get the remainder. You might think that that's actually not a terribly useful thing, but you'd be surprised actually by how frequently that modulus operator can come in handy. There's a couple of problems we'll do in CS50 that deal with it. And it's also good for doing things like random numbers. So for example, if you've ever heard of a random number generator, that's going to give you a number from 0 to some huge number, but maybe you only really need a number from 0 to 20. If you use the modulus operator on that giant number that gets generated by the random number generator, you're going to take whatever huge value it is, divide it by 20, and get the remainder. The remainder can only be a value from 0 to 19. So you use modulus operator to take this huge number and whittle it down to something a little more meaningful. I'm pretty sure you'll be able to use both of those at some point in the future in CS50. So C also gives us a way to apply an arithmetic operator to a single variable in a little more shorthand way. So on the previous slide, we saw x equals x times 5. That worked. X times 5 then gets stored back in x. There's a shorter way to do it, though, and there's the syntax x times equals 5. It's the same exact thing as saying x equals x times 5. It's just a slightly shorter way to do it.
X times equals 5. This trick works well with 5 basic arithmetic operator. C provides a further shorthand for incrementing and decrementing variable 1.
And when you see some distribution code or you see some sample code that does things like this, just be familiar with what the syntax means. You certainly don't have to use it, but if you do, it might make your code look a little slicker. And know that you can also use any of the different operators we've already seen before instead of times. So you could say x plus equals 5, minus equals 5, times, divide, and mod. All of those work. There's also something that's so common in C that we've decided to refine that even further. Incrementing a variable by 1 or decrementing a variable by 1 is such a common thing, especially when we talk about loops a little later on, that we've decided that instead of saying something like x plus equals 1 or x equals x plus 1, we've even shorthanded that to x plus plus. So x equals x plus 1, x plus equals 1, and x plus plus all do the same thing. They all increment x by 1. But that incrementing and decrementing by 1 is so common that we have plus plus and minus minus that allow us to shorthand that even further. So let's switch gears for a second and talk about Boolean expressions, all of which are also kind of fall into the overall category of operators. But Boolean expressions, unlike arithmetic operators, are used for comparing values. So again, all Boolean expressions in C evaluate to one of two possible values, recall, true or false.
Are
you done?
No.
Okay, get out of here. Go.
False. That's the only two values a Boolean variable can take on. We can use the results of a Boolean expression in a lot of ways in programming. In fact, you'll be doing this quite a lot. For example, we might decide, well, if some condition is true, maybe I'll take this branch down my code, a conditional, so to speak, and we'll learn about those soon too. Or maybe as long as this is true, I want to keep doing this over and over and over, a loop. In both cases, know that we're using a Boolean expression, a true or false, to decide whether or not to take a particular path.
Mm-hmm.
Sometimes when we're working with Boolean expressions, we will use variables of type bool. You might have declared a bool type variable and you'll use it in your Boolean expression, but you don't always have to. As it turns out in C, every non-zero value is the same as saying true. If you had declared a Boolean of a variable of type Boolean and assigned it the value true, that's the same as declaring an integer and assigning it the value 1, 2, 3, or really any value whatsoever other than 0. Because in C, every non-zero value is true. 0, on the other hand, is false. This might come in handy later on to know. It's just something to keep in mind. We don't always have to use Boolean type variables when we are working with Boolean expressions. There are two main types of Boolean expressions that we'll work with: logical operators and relational operators. The language there is not terribly important. It's really just how I'm grouping them. And you'll certainly, I think, quickly realize what a relational operator is based on what they are when we talk about them in a second. But don't worry about necessarily memorizing the term logical operator or relational operator. I'm just using it to group them in a logical way. So let's take a look at the 3 logical operators that we'll see quite a bit in programming in CS50 and programming more generally. Logical AND is true if and only if both operands are true, otherwise false. What does that mean? So let's say that I am at a point in my code where I have 2 variables, x and y, and I want to decide whether to do something in my code based on if x is true and y is true. I only want to do it if both of them are true. Otherwise, I don't want to go down that path because it's not going to help me. What I can say is if x ampersand ampersand y. That will be a logical Boolean expression comparing x and y and taking a certain path based on what their values are. So if x is true and y is true based on this truth table here, only then will we go down that path if x ampersand ampersand y. It's only true. The AND is only true if x is true and y is true. If either one of them is false, as we see in the truth table, then both x and y are not true. And so x ampersand ampersand y is false. Logical OR is true if and only if at least one operand is true, otherwise false. So logical AND required both x and y to be true. Logical OR requires x to be true or y to be true or both x and y to be true. So again, we kind of find ourselves in a situation where we're going through our code and we've reached a fork in the road and we want to go down a particular path if x is true or if y is true, but not necessarily if both are true, but possibly if both are true. So if x is true and y is true, we'll go down that path. X is true, one of them is true, right? If x is true and y is true. If x is true and y is false, one of them is still true. So x or y is still true. If x is false and y is true, well, one of them is still true, right?
Okay.
Y is true in this case. So it's true that x or y is true. Only if x is false and y is false do we not go down that path, because neither x nor y is true. Now, if you're looking at the screen right now and wondering what that symbol is for logical OR, it's called the vertical bar. And if you look at your keyboard for a minute, as I'm doing now, it's usually just above the Enter key on most keyboards, on the same key as the backslash. It's also usually right next to the square brackets. So it might be a key that you haven't typed very much in the past.
Never.
But if you're ever doing logical comparisons, as we'll be doing a lot in the course, it's going to be useful to find that key and use it. So it's usually on the same key as backslash, just above Enter. The final logical operator is not, and not's pretty straightforward. It inverts the value of its operand. If x is true, then not x is false. If x is false, then not x is true. Sometimes you'll hear this symbol pronounced as bang or exclamation or not. They're pretty much all the same thing, but in case you hear
Dang, I done forgot my make. Oh, is it make? No, it's dot backslash agree. Oh my goodness, I done forgot how to make my thing. Dang, that's crazy. Gotta keep this fresh. How do I compile? Give me a short answer. This thing will be hella verbose and give me a long answer. Make hello. What the hell was I said? Make agree. Make agree. Huh. Well, let's tap into my rubber ducky. I don't know why my code is, what's the error for? Oops. Just Control C. I don't think I can Control C that. Control L. Make agree. Okay, there's something wrong with my code. Oh, it's these. It's right here. I forgot the end of this quote. Boom, right there. There we go. Oops. Down here in my terminal. Make agree. After expression, make agree. Oh, I gotta do space. Make agree. No, I'm still getting the error. Print F agreed dot. Do I put the end quote right here? Is that what it is? And then come over here. Backslash n. Let's see if that. I forgot to compile it. That's why. I forgot to compile it. Let's just see. Looks like you're working on a program that asks the user if they agree. Do you have any specific question you should code facing? I'm getting an error. I can't, girl. I said, girl. Let me see. I don't know how to copy and paste the damn. Control C. How can I copy the error in terminal without doing this damn up arrow? I don't even know where that character is at. Okay, let's see. Terminal. Boom. Let's see what we got. Terminal, you can usually copy text by highlighting it with your mouse and keyboard. Control C to copy. You can paste here. That's what I'm doing, was giving this damn this. Nope, don't do that. Nope, don't do that. Control C, Control C. Why is it doing that?
Yeah, I gotta go party.
Let me see.
Gotta go party.
Let me see. Okay, so where's that damn up key at? Damn, my typing was way off. I know how to copy and paste, but it's not letting me. That's the problem. I'm going to do Control L, clear, make, agree, get the error. So maybe I'll come over here. I got to do all this maybe. That is not. I said Control L, motherfucker. Control C, Control C, Control V. See, it's doing all this. Open in file editor, Control click. No, I don't want to do that. Control C, my nigga. That's crazy. Watch. Control C keeps typing this. My control C ain't working. It seems like control C is being interpreted as a command to stop a running program in terms of copy. To copy the text, try using your highlight text. Oh, I gotta do it the old school way. I can't even do that. Oh, I gotta grant access. What the heck? Let me refresh this whole thing because that's just weird. There's a bug in the program itself. That's just hella strange. All right, terminal. All right, so let's trash this terminal altogether. Open. I thought I already logged in. Is that why? Because I'm not logged into my damn. Shouldn't be it. Okay. That is crazy. I don't know why it's doing that, y'all. I guess it printed. I guess it worked. Yeah, it did. The error message indicating that there is a missing semicolon. Oh man, I'm tripping. Let's try that. Make agree. There we go. That semicolon. I knew it, but that's why I practice, man. You gotta practice. All right, so now we got dot backslash agree. Do you agree? Oh, why? Because it's a char. Char stands for character. Get C equals char equals get char. Do you agree? C equals y. If y. Okay, so that's working. I just had to refresh my memory with that real quick. Okay, now let's get back to it.
It's just the exclamation point, but sometimes it's called a couple of different things. All right, so that takes care of logical operators. So let's talk about relational operators. Again, if you're familiar with this from arithmetic back in grade school, you're probably familiar with how these work already. These behave exactly as you'd expect. So less than is true in this example if x is less than y. So if x is 4 and y is 6, x is less than y. That's true. Less than or equal to works pretty similarly. If x is 4 and y is 4, then x is less than or equal to y. Greater than, x is greater than y, and greater than or equal to, x is greater than or equal to y. If it's true, then you'll pass that expression and you'll go down that path in the road. If you have an if x is greater than y and x in fact is greater than y, you'll do whatever is subject to that condition. Notice that we don't have a single character for less than or equal to, as you might be familiar with from math textbooks. So we have the less than symbol followed by an equal sign. That's how we represent less than or equal to. And similarly, we do that for greater than or equal to. The final two relational operators that are important are testing for equality and inequality. So if x equals y is true if x and y's value is the same. If x is 10 and y is 10, then x equals y is true. If x is 10 and y is 11, x equals y is not true. We can also test for inequality using exclamation point or bang or not again. If x is not equal to y, then if that's the test we're using here, we'll be good to go. So if x is not equal to y, we'll go down that path. Be really careful here. It's a really common mistake, and one I certainly made quite a lot when I was getting started, to accidentally mistake the assignment that you sneak it by, though. Just so if you are doing an equality test, if you're checking whether two different variables have the same value inside of them, make sure to use equals and not single equals. And that way your program will have the behavior you intend. I'm Doug Lloyd, and this is CS50.
Thanks, Dougie, my boy. Dougie Fresh. All right, shout out to Doug, man. Doing the damn thing. So we got that. No, I don't. They keep trying to buy me. Let me buy this one. I'm not gonna buy it. Maybe if I make some money off this, I'll buy it. But Anyways, let's go to conditional statements. I guess it's the prerequisite to the next video, so we'll just go over this. This is what we're going over.
All right, so now
Conditional
let's talk about
statements.
something really useful in programming, conditional statements. So conditional expressions allow your programs to make decisions and take different forks in the road, something I alluded to a little earlier, depending on the values of variables or based on what the user inputs at the program or at the command line, or if you have a prompt or something like that. C has a couple of different ways to express conditional expressions, which we also sometimes will call a conditional branch in your programs. And some of these are going to look pretty familiar to you from scratch. So we'll even pull them up side by side just so you can make that analogy in your head. So if is a pretty simple conditional. If you recall from scratch on the right here, you could fill in that hexagon with a Boolean expression, if mouse down, or if x is less than 10, or something like that. And then if x was less than 10, or if the mouse was in fact down, all of the code inside of the puzzle piece would execute, all the things that fit inside that C shape. Similarly, do we have if on the left there, if Boolean expression, which I'm just using as a substitute for one of the Boolean expressions we've previously discussed, open curly brace, close curly brace. So think of open curly brace and close curly brace as sort of analogous to the sandwich effect of the if block on the right from scratch. If the Boolean expression in the if statement is true, then all of the lines of code between the curly braces will execute in order from top to bottom. If the Boolean expression is false, we'll skip over everything in between the curly braces because we only want to go down that fork in the road if the Boolean expression is true. We can take this one step further with if else. So this scratch block is pretty similar to the one we saw just a second ago, except it takes two different paths based on what happened. So if the mouse was down, or if x was less than 10, we'll do everything that's in between that first fork, that first C. Otherwise, if the mouse is up, or x is not less than 10, we will do everything in the second set. And that's analogous to what you see here for C. If Boolean expression, do the stuff between the first set of curly braces, else do the stuff between the second set of curly braces. So if the Boolean expression is true, we'll do whatever's between the first set. If the Boolean expression is false, that would trigger the else, and we would do whatever is in the second set of curly braces. Again, top to bottom, all the lines in between the braces. In C, it's possible to create an if, else chain. And in fact, you can have if, else if, else if, else if, and so on and so on and so on. In Scratch, this required nesting the blocks. You had an if else, and then you had to put another one inside of the else, and so on and so on. And it got kind of nested and complicated. But C, we don't have to do that. We can actually just have it be a chain like this. Again, as you might expect, all of these branches are mutually exclusive. You can only ever go down one of the branch. If this is true, otherwise, if this is true, otherwise, if this is true, otherwise, do this. So all four of the branches in this example are mutually exclusive. It's an if, else chain. It is possible, though, and sometimes very useful, to create a chain of not mutually exclusive branches. In this example, only the third and fourth branches are mutually exclusive. It could be that you could satisfy the first condition, and you could satisfy the second condition, and you could satisfy the third condition, in which case you would go down the first branch, then you would go down the second branch, then you would go down the third branch. Or perhaps you satisfy the first condition and the second condition, but you don't satisfy the third condition. In this case, you go down the first branch and the second branch, and then the fourth branch. The reason for this is that the else will only bind to the nearest if. So even though there's an else here, that doesn't necessarily create a mutually exclusive chain of everything. It's only that the expression there with Boolean expression 3, that's the mutually exclusive with the else. So it is possible, and sometimes quite useful, as I said, to create a chain of not mutually exclusive branches. Let's take a look at a different kind of conditional, which you have not seen before in Scratch. There's something called the switch statement. The switch statement is kind of neat because it's a conditional.
See, switch statement is a conditional statement that permits enumeration of discrete cases instead of relying on Boolean expressions. It's important to break between each case, or you will fall through each case unless that's desired behavior. Okay, let's break that down, because that's a. Can you simplify what was it called? Damn, I forgot already. Switch statement. Switch statement is in C. Give me 3 examples and 3 analogies. And then let me. Somehow my computer got unplugged. Okay, let's find that. Okay, now let's go back here for a second. Let me explain switch statements using some everyday analogies first, then show you the code. TV remote analogy, switch channel. Case 2, print NBC. Case 2, print NBC \n break. Case 4, print F Fox break. Think of it as pressing the button on your remote. Each channel number takes you to a specific station. Switch channel. Is that how he had it in here? Switch X. Int X equals get int. So he's saying we got to enter a value. Switch. So the switch is channel, whatever it is, or X. The switch is X. So okay, so pretty much whatever we put in, that's what int is going to get. If I'm understanding that right. Let's look at the next analogy. Think of it like pressing the button on each number. Okay, restaurant menu analogy. Switch, menu choice. Case 1, print F, preparing burger. Break, print, preparing pizza. Okay. Like telling a waiter your order number, each number corresponds to a specific dish. Traffic light analogy. Red, yellow, green, light malfunction. Like a traffic light, each color tells you exactly what to do. Key parts to understand. Switch looks at one value, like checking what button was pressed. Case is like saying if it's this value, do this. Break means we're done, exit the switch. Default is like saying if none of them above, do this. Think of switch statement as a simple way to write multiple if else statements when you're checking the same variable against different values. It's particularly useful when you have many possible values to check. Would you like to explain? Okay, how is this typically used in a script? What is the real world application for switch? Can you give me 3 examples of how this, what is this, conditional statement? This conditional is used in everyday code for the average person. Let's see what we got going. Let me walk you through 3 real world applications of switch statements that you might encounter every day. Mobile app menu. Okay. Selection case H. Display home page. When user taps home, go to the home page. Okay. Case P. Profile. When user taps profile. Okay. Mean selection. Okay. Option setting or open settings. When user taps messages. Oh, okay. So it's like, I get it. That makes sense. This is similar to how your phone's apps handle navigation. When you tap different icons, the app needs to know which screen to show you. Dang, that's a lot going on in the background when you think about it. Because when you download the app, it's putting in new code into your phone. I never even thought about that. From input validation, like when shopping online, switch payment method, process debit card, ask for card number, user process PayPal, redirect to PayPal, process Apple Pay, initiate Apple Pay, show payment error, return home. Okay. That's like when you're checking out online, selecting payment. The website needs to know which payment process to start. Got it. Okay, we on to something. Game character movement. See, then this is why I couldn't. Because let me show y'all something. I was working on Scratch my damn self. Oh dang, that's Scratch. And I had cut out these sprites. Where my project at? Oh, what? Don't tell me my project ain't saved. Time out. Oh no. I'm about to be pissed. Whoa. Chill. Oh, okay, I was about to say. So check this out, y'all. I was working on this project right here. Where's my green flag? So I got Naruto here. You feel me? And he's glitching a little bit, but you see the vision, right? I don't know why he goes that way. We're gonna have to work on that. But I think this is why. I think why he keeps going every direction is because I need this, the switch. Because I can't do else if like the keys. I need too many keys. I don't know if that makes sense, but I'm actually kind of proud of this. But I don't get why he going to the. I need him to go negative when let's go 3. Oh snap! There we go. I just don't get why he glitching like that though. Just go through the full animation, my boy. When right arrow key press, not repeat until not right arrow key press. Right. Three steps, point one. I don't get why he going up like that though. Need him to stay on the ground. It's all good though. Y'all see me? I'm out here coding a little Naruto game. In Scratch though. Okay, so I need a switch statement. That's what I'm learning. This is how many games handle keyboard input. When you press different keys, your character moves different directions. The key thing to understand is that switch statements are particularly useful when you have a single variable that can have several different values, and you need to do different things based on the value. It's like having a central control panel where one lever can direct things to different paths. Did I talk about that in this chat? No, I didn't. All right, let's go back to my boy.
Statement that allows you to specify distinct cases instead of relying on Boolean expressions to make decisions for you. So for example, let's say that I have this program and I'm asking the user to provide input to me. So I say int x equals getInt, and if you're not familiar yet, getInt is a function that is also included in the CS50 library. So if you pound include cs50.h, you'll have access to getInt and all of its cousins, getFloat, getString, and so on. Basically one get function for every data type that we've already discussed. So int x equals getInt. Basically what's happening is I'm at the terminal, I'm asking the user to type in a number. And here I'm switching what I'm doing depending on what the user typed at the prompt. So if they typed 1, I print out 1, and then I break. If they print 2, if they typed 2, I print out 2, and then I break. It's important to break between each case because otherwise you will fall through. So if I didn't have any breaks there and the user typed 1, what would happen is it would print 1, 2, 3, sorry. That's kind of strange behavior, right? You might think so, but there are actually some cases where this could be a pretty useful thing. So here's another example of a switch statement where I omit the breaks, but I do it on purpose. So what happens here? Think for a second. You might even want to pause the video. What happens here if the user types 4?
It's going to go 3, 2, 1, blast off.
So I've asked the user for input, and they provide the value 4. What gets printed when I do that?
4.
On the previous slide, there were breaks between all of the cases, and so it would just print 4 and then stop. But in this case, it won't. What will happen is you will fall through each case. So in this case, I've organized my cases in such a way that if the user types 4, I will print 4, 3, 2, 1, blast off. And if they typed 5, I would start at 5 and do the same thing. And if they typed 1, I would just do 1, blast off. So in this case, I'm using a switch kind of cleverly so that I do intend to fall through all the cases. But generally, you're probably going to want to break between all of them unless you have a situation like this one where you're kind of leveraging the fact that you'll fall through the cases without a break. So that's the second of the major types of conditional statements, the last of which is question mark colon. So I have two snippets of C code here, one on the left and one on the right. The one on the left should probably be pretty familiar to you. I have int x, and I probably should have, ask the user for, it should probably be int x equals getInt or something like that. And then I'm making a decision. If some Boolean expression is true, assign x the value 5. Otherwise, assign x the value 6. That on the left should probably be pretty familiar from our discussion of if-else just a moment ago. Would you be surprised to know that the line on the right does the exact same thing? So this is called question mark colon, or sometimes called the ternary operator. And it's pretty cool. It's usually used as a cute trick. But what it allows you to do is to simulate an if-else with really small, really trivially short conditional branches. You generally wouldn't use question mark colon if you had 6 lines of code between each set of curly braces. But if you're just making a quick decision, if you're going to do one thing or the other, and it's very simple, this might be an example of how to do it with question mark colon, the ternary operator. So int x equals expression, question mark. The thing after the question mark is what x's value will be if expression is true. The thing after the colon is what x's value.
Slow down, my boy. Let's break that down. Let me go back up here and copy and paste this prompt I got because my boy went off to the matrix with that. Copy this. Boom. Can you simplify what? So I need to know what this is. X. and ternary statement. Is that what he called it? Ternary statement. Let's see. Ternary. Yep. See what they're talking about. Let me explain ternary statements by starting with something familiar and building up to the concept. A ternary statement is a shorter way to write an if-else statement. Think of it as a quick decision maker. Let's look at it both ways. Regular if-else. If age is less than or equal to 18, the status equals adult. Else, the status is minor. A minor. Shout out to Kendrick winning them Grammys. Some things, same thing as a ternary. Status equals age greater than or equal to question mark adult slash minor. Let's break this down with 3 real world examples. Status equals age greater than or equal to 18. So it's saying that this is the else. This is the if, this is the else. I'm guessing. Let's break down ticket pricing in 3 real examples. Price equals age less than 12, 5 or 10. So if they enter, is it a child ticket or adult ticket? So if they enter anything less than 12, it's $5. If not, it's a 10. So think of this like a ticket booth. If you're under 12, you pay $5. Otherwise, you pay 10. Game score. Score is greater than or equal to 100, you win. If not, game over. Like basketball scoreboard. If you hit 100 points, you win. If not, game over. Temperature warning. Warning equals temp less than 32. If less than 32, ice warning. Else, safe to drive. Like whether it's below freezing. Say safe to drive. Instructions always. Result equals condition. Value of true, value of false. Think of it like these everyday situations. A light switch with motion sensor. Someone moving, turn on, turn off. I like that one. That's a good example. Restaurant seating, group size, bigger than 6, big table, small table. Okay. Umbrella decision. Is raining, bring umbrella, leave umbrella. The term ternary means composed of 3 parts, which is why it's called ternary operator. It has a condition, the question. What happens? First answer. Would you like me to show you? So, pretty much what's in parentheses. Oh, I spelled that right. Colon is else. Is that accurate? Is that accurate? Let me break down your understanding to confirm and expand. The ternary operator has 3 parts. That's why it's called ternary. Age equals the question is age 18 or more. Means question mark if true, then it means otherwise else. Let's compare it to regular if else, see if the parallel. If age is greater than as result equals adult. The result equals age. Think of it like a quick question and answer. No, I wouldn't now right now.
value would be if the expression was false. So I'm asking myself, is the
Yeah, but what's the expression? What's the expression? An expression in programming is any piece of the code that produces a value. Think of it like a math problem that needs to be solved. When you see 2 plus 3, your brain automatically knows this expression will give you 5. Here are some different types of expressions. Arithmetic expression. Int result equals 5 plus 3. Addition expression. Int price equals quantity times 10. Multiplication expression. Boolean comparison expression. Boolean is hot. This is like asking the questions that you have yes, no answer is hostile, or am I tall? Logical expressions. Boolean can enter club. Age greater than or equal to 21. And has ID true. Then get a club. Like bounces decision process, you need 21 and have an ID to get in. Think of expression as questions or calculations that give you an answer. When you say how old will you be next year, the expression would be current age plus 1. Do I have enough money for lunch? Expression is my money plus or my money greater than or equal to lunch cost. Should I bring my umbrella? The expression might be is raining. Oh, what is those horizontal lines mean? Oh, if either of them is true. Every expression evaluates, reduces to a single value. Just like every math problem has an answer. Okay, that makes sense. Kinda. You're on the right track, but let me clarify a bit further. All right, you don't gotta do fucking 3 examples for every fucking time. You're on the right track, but let me clarify a bit further. An expression is actually broader than just a question. It's a combination of values, variables, and operators that can be evaluated to produce a result. Think of expressions like a recipe that always produce something. Oh, it's the answer. It's the answer. Don't try to confuse me. More like the recipe or calculation that gives you to the answer, not the answer. So the expression is the process that will produce results when it's evaluated. Ain't that what I just said in the first one? So expression is just the question that gets the return value. So the expression is the question. You said the right side of the. You said it's on the right side of the thing. It's probably.
Yeah, I got another t-shirt for her too.
Okay, all right. Side. Expression is the entire calculation process. It includes both what you're asking, calculating, and how you'll get to the result. Okay, well, I might have to take a break here soon. You know what? I get it. I do get it. Expression is the question and the answer. That's how I'm gonna say it. I'm not gonna let him confuse
The
me.
expression true? If it is, assign x the value 5. If it's not, assign x the value 6. Again, like I said, this is usually just a cute trick, and sometimes if you become really comfortable with it, you'll do this because it looks kind of cool in your programs. Generally, I'm presenting it to you now so that you're familiar with it if you see it. But certainly no, you don't have to write it in any of your code, but it is something to be familiar with because you'll definitely encounter snippets of code here and there where this question mark colon syntax, aka the ternary operator, is used. So a quick summary on what conditionals are and what the options are available to you in C. You have if and if else and if else if, etc. You can use Boolean expressions for those to make decisions. With switch statements, you use discrete cases to make decisions. You explicitly say, if it's 1 or if it's 2 or if it's 3, I'll do this thing or this thing or this thing. And question mark colon can be used to replace very simple if else branches or if else chains to make your code look a little fancy. I'm Doug Lloyd, and this is CS50.
Thanks, Dougie boy. All right, y'all. I think we're gonna call it quits right there, man. I got these 2 videos down. I'm going to Harvard, y'all. Shout out to me. Get this computer science degree. Let's look at the syllabus. Let's see where we're at, y'all. So, 10-week program. I accidentally started this artificial intelligence one. I didn't mean to do that. How long is this video?
You bounce this ball against the bricks and the bricks disappear. But let's try a slightly more sophisticated.
Is this a part of the program? Okay, well, syllabus. C arrays, Python week 6. Hey, we're about to blow through these, y'all. We better get this done, man. We're not about to wait till week 6 to. Well, we might, but I'm probably gonna have to watch this all once and then like redo it. But so yeah, y'all. I mean, I'm just kind of going through this. Toward the bottom of each problem is a section to tell how to submit. Follow instructions there and to submit your problem sets. And within a few minutes, you should be scores by CS50. I did join the course. The hell are they talking about? I got homework for real. $23 contributors in the last year. Oh, it's a whole thing right here. Okay, well, we're going to have to figure that out. Hello, world. It's CS50, aka CS50X through EDX, Harvard University Introduction to Intellectual Enterprise, Computer Science, and Art of Programming. You're welcome to take this course at your own pace, starting whenever you like. So don't worry if this is your first time here. Don't worry. Okay. If you're YouTube type, if you're TikTok type, if you're LinkedIn type. They got everything. Okay, but how do I submit this though? Oh. Okay. Okay. Okay, so I got to submit that. Okay, well, I'll get back to problem set 0. Got to get that done. Well, yeah, y'all, that's all I got for today. I'm about to peace out for now. I know I didn't type a lot of code, but it's all good, man. I'm learning all these terms, and it's not overwhelming, but it's just interesting to do all this. I ain't gonna bore y'all no more. My rants. Appreciate y'all for tapping in, man. Like, subscribe, share, comment, all that. You heard? All right, peace.